Hey y'all, welcome back to Database School. Today I have the other half of the Prisma founding team, I guess. So I have Johannes Schickling here, and he is the original founder of Prisma, and he's here to talk about his new project, which is still in the database space, but quite a bit different. So welcome, Johannes. Do you want to give a little intro for yourself, and then we can dive in?
Yeah, thank you so much for having me. Yeah, I can't kind of help myself gravitating back to the data space one way or another. It's sort of like in this loop of where I'm trying to build an app and then get frustrated by some part, and typically frustrated by something in the data layer, and then I'm trying to build myself like a little data system that helps me build this app. And I'm currently like in both phases of that loop. So I'm building LiveStore, which is a local first data layer, and I'm working on a music app called Overtone, which is supposed to be like a third-party music client, similar to how apps like Superhuman give you a really great mail experience where you can add Gmail, etc. I want that for music, so we can talk about both. But yeah, this is not
So
my
you're
like.
you're a you're a classic developer in that you're building a project, you're building a music app, and then you're like, man, I really need some better tooling. And then you go off. And how long have you been building LiveStore now?
Yeah, so I moved on from Prisma in 2020 and started exploring various other things there. So I took a sabbatical, wanted to figure out like, hey, am I gonna am I staying with this chapter or am I exploring something new? And what I realized is like I wanted to be like going back in the shoes of a builder again. So and so many things have changed at that point in time. And I basically just started exploring a whole bunch of different things. And a friend of mine who's currently running the Ink and Switch research group, Peter van Hardenberg, I've been staying in close contact with him. And he kind of shared a lot about the ideas of local first with me at that point. And I started looking into that as well. And that really clicked for me. I've been always like kind of on the lookout for big levers that help really make app development better. And so this is where, and I'm also typically an early adopter of technology. So I was one of the earliest adopters of Docker back then and React. And so this is where where I finally saw, okay, this is a kind of an interesting, different way to think about data management. I don't think it's just a totally better way. It's just a different way. And like in data, it's all about trade-offs. And this is where I started like poking around there. And one thing led to another. I got then involved in a PhD thesis of a friend of mine who did his PhD at MIT about this project called Riffle. And the premise of that was that you take SQLite, and that now runs everywhere through WASM, etc. And taking SQLite, making that the foundation of a state management system. So think about it like Zustand or Redux or MobX, something like that, but like an even more sophisticated state management foundation, which SQLite gives you. And Riffle was exploring adding reactivity, etc., and all of the good stuff you have from a modern JavaScript state management system, marrying that with SQLite. So that was Riffle, and that I was involved in over 2 years, and that subsequently led to LiveStore as the successor project. So I've been really working on this for more than 4 years at this point.
Wow.
All by myself.
Okay, so let's back up. You founded Prisma. You worked on that for a little while, and then you brought in Soren, whom we've had on the show. So now we get the
Yeah.
whole Prisma crew. Brought in Soren. Y'all worked together for a while, and then you decided, hey, I'm going to take a little sabbatical. And then, as one does, you went and helped somebody do their PhD thesis at MIT. Very normal stuff. Everybody's done it. And then you got kind of involved in this local first syncing thing and started to, well, I guess you wanted to build an app, and then you were like, well, let me first invent a brand new piece of software, piece of technology, and then I can finish building my music application. So what is the, I guess, before we dive into what LiveStore actually is, can you help me understand the landscape of local first? Because I feel like I've seen a lot of this local first stuff popping up, and I've had a few people on the show that have talked about local first and sync engines and all of this stuff. Can you help me understand like the broad landscape and kind of where you and LiveStore fit into that landscape? Hey, I hope you're enjoying this. Just as a reminder, you can learn more about SQLite at highperformancesqlite.com. I'll get out of your way. Back to the interview.
Yeah, totally. And speaking of landscape, I'm also running this podcast, Local First FM. And on that podcast page, we put together a resource called the Local First Landscape. So Local First FM / landscape, where we tried to just provide a lot of information about all the various tools in that space. It's a very rich and broad space with many different approaches, many different trade-offs, really, where it's mostly like apples and oranges, like and a whole gamut of like different fruit and vegetables. So two technologies are always like pretty tough to compare, since they often like try to like cater to different use cases. So the local first space, I think there's kind of two camps, I would say. There's let's call them pragmatists, who are coming to local first mostly for the syncing. And this is where you have great technologies such as Electric SQL or something like Zero. And those are great technologies for folks who are kind of more traditional app developers who just want better building blocks to get stuff done faster, which I also count myself to that camp. And then there's another camp where they're in local first more for the ideals. So local first, the folks at Ink and Switch coined the term local first in their essay, where they outline the 7 ideals of local first. And that is not just about like fast data, no loading spinners, but that also goes like all the way towards like the users owning their data, having agency over that data, that there's like no third party who kind of like locks everything in. So that is more like for the idealist, which I also very much appreciate. And I would love all of those ideals to become real, but that's like a much bigger lift. So I see it basically as like those two groups, they probably want the same thing. Some think a little bit more like Galaxy Brain decades in the future, and the other want fast apps today at the expense to maybe where it's still more centralized, etc. So that is how I would broadly group up the local first landscape. And there's many flavors and many variants of the technologies.
And why do you think local first has become so popular in the past, we'll say 3 to 5 years? Is there a technology enablement that happened? Is there something with the nature of browsers that happened? Or is it just the zeitgeist move towards, well, if we're going to go faster, we got to get the data closer?
Yeah, so I think the last point you've made, I think already is a really good proxy for that. So I think there's multiple reasons. There's certainly technological advances where things are possible now. For example, browsers now supporting WASM, etc. Everything has advanced, so there's a certain unlock there. But besides of like the technological possibilities now, I think there's also a couple of like lighthouse app examples. Linear, for example, comes to mind. And Linear really falls into that pragmatist camp. They famously have built their own sync engine, which allows them as a company to mostly have front-end engineers. They have a small team of the folks who are like building the sync engine, but most of the rest is really all about front-end developers, which allows them to build those like high quality products that it's those high quality experiences that their product is loved for. And I think that has inspired a lot of people. Like one of Linear's like company values or aspirations is to inspire other builders. And I think they're really succeeding at that they want to set a high bar for what a product can feel like. And I think the unlock to build those high product experiences is data, is fast data. And like when you're dealing with data, it's all about like how you click, you interact with the app somehow, and it should give you the thing that you want from it. And the longer this needs to round trip to a server, etc., the worse the experience is. And I think they've kind of like understood this very early on, that they said like, hey, to give you the snappiest experience, we got to have that data all local. And I think that, as a lighthouse example, has really shed a big light beam on that space. And then I think another one is that like we've kind of running to a point where we've kind of tried out like most permutations of like what a web framework can be like, and like overall things have come a long way. I've been I know you're a big Laravel fan. I've been like part of the early Laravel community as well, and that has really shown me like how a great developer experience can be like. But there's just like a lot of API improvements like ergonomics, etc. But the underlying architecture was not really challenged or rethought for, at this point, like 1 to 2 decades, really. And this is, I think, where local first is so much bolder, and what spoke to me in 2020, that I more or less dropped everything and thought like, okay, there's really something there that provides an interesting, attractive, different take on this. And that is fundamentally about like, let's bring the data as close to the user on the user's device. And if we start making trade-offs all around this, there's some really attractive user experience possible from this. Won't work for all apps, but for certain kinds of apps. And I think particularly now also with AI apps, where everything is so personal and contextualized, I think that's another really interesting trade-off.
So it sounds like a multitude of factors: the WASM stuff and SQLite being around since forever, and then being able to run in the browser. But what I'm hearing is that Linear did it, and everybody was like, "Oh, this is better. Let's like build the tooling to make this available to the people." And so that's kind of the explosion of the local first tooling. So a combination of technological, somebody showing what's possible, and then, like you said there at the end, rethinking the traditional decades old web app paradigm. That makes sense to me. And it does seem like these things happen where like 3 or 4 factors come together at once in different areas, and then something becomes incredibly obvious. And it sounds like that's what happened here. So you're building Overtone, you're building this music thing, and you're looking around and you're like, oh boy, this needs to be better, faster, more responsive, snappier. And you look at the to say landscape again, you look at the landscape of local first, and something is missing. So when you looked out there and you were like, I could use something like this, but it doesn't meet my needs, I'm going to build LiveStore. What was the gap that you identified when you reached out and were like, let me find something? Shoot, there's nothing here. What was missing?
Right. So I should say that back in 2020, that like landscape had way fewer like technology columns as today. So
makes sense.
Even if I got started today, the kind of column technology that I'm looking for would still not be there. So I would still today probably come to the same conclusion and build it. But back then there weren't any alternatives either, or like very few. There were some like more OG local first technologies that have been working on that like for like over a decade, really. Like something like CouchDB, etc. comes to mind. Those ideas have been tried, and even though the term local first has picked up a lot of steam over like since 2020 or so, the ideas have been around for much longer. And like, yes, Linear is sort of the lighthouse example here, but some of the OG apps are actually like, for example, how mailing works. Like a mail client is sort of like the OG local first app, because this is already like, you always had your mails locally back in like when you had the first Outlook versions, etc. Like this worked all offline. So this was like by default, your computer was mostly offline unless you like beep, beep, beep modemed into the internet. And so another group of like OG local first apps is like most of the Apple apps. For example, I'm an Apple user, and if I need to pin down a thought very reliably and very quickly, I open the Apple Notes app because I know this works in every circumstance. Whether I'm on a plane, whether I'm somewhere in the forest, in a parking garage, I can just pull it out and write it down. So those ideas have been around for quite a long time. And there's various kind of more pioneering technologies that tried to accomplish that before, and they had a much harder time to get there for those technology constraints. So another technology that comes to mind here is Realm, who got acquired by Mongo way later. But they tried to already do that way earlier, but they didn't have those tailwinds that we have these days, where WASM runs everywhere. Also, like the problems are more felt. I'm a big believer in like that the technology is successful. There needs to be a problem first that people have experienced for this problem to resonate. And I think for those technologies, the right time hasn't come yet. So back in 2020, I looked at the landscape, and there was very, very few, and there were already a few folks who kind of were getting on the same path. But I think just over the last couple of years, like all of those technologies popped up more. And they're also, when you try something new, you might not get it right right away. And so, for example, the folks who are building Zero, the folks from Rosie Corp, they had two prior product approaches that they're now deprecating or deprioritizing now in favor of Zero. So this is a fairly new emerging space where still many things are being tried out. But what was, aside from like the particular technological decisions, what was clear for me is that if I want to build an ambitious app, then the bottleneck that holds me back to make this app become a reality is data. Since most of the other things are really like, we're in a pretty good shape already. Something like React, Solid, Svelte, all of those things are fantastic foundations to build something. Building for the web in particular, we have so many great options, but also on mobile, it's pretty decent to build something in Swift UI or React Native or for Android. But what about the data story? And particularly when you want those snappy user experiences, this is where I felt, okay, this is where we still don't have the React equivalent for data. And this is where I see the promise in local first and syncing.
You know what? That is very interesting to me. The fact that we do have, I won't call it a solved problem, but close to a solved problem on the front end with these great, battle-tested frameworks. A lot of innovation has happened there. But I agree, the data layer has not had the same like explosion of innovation and frameworks and stuff. And so that actually makes a lot of sense to me as to why now, like why these things are popping up now, because all of that problem solving energy has to go somewhere. And like React already exists, let's put that energy somewhere else. So talk to me about LiveStore. So give me the high level overview of like what problem it solves and how, and then we can dig into some of the technical details and trade-offs and decisions you've made in the process.
Right. And I'll start here by saying to follow up on your point, like that we don't have those data frameworks, and to contrast how LiveStore is designed compared to Prisma. With Prisma, I tried to meet people where they are. And no matter which kind of app people build, no matter which kind of architecture they're building for, as long as they're using TypeScript, as long as they're using one of the common databases, Prisma works for them. So it was very unopinionated, and it tried to bring like TypeScript, etc., like typing to developers. With LiveStore, I'm taking a very different approach. I'm very opinionated. I'm very opinionated about a particular architecture, about a particular data design, and I'm trying to like only cater to that. And I believe that for data, this is where the mantra, like it depends, applies ultimately. I think you can only provide a lot of value for a particular sliver and a particular kind of architecture. That's like already philosophically kind of, or from the goal setting perspective, very different to what I've tried to do before. So with that out of the way, like LiveStore is trying to be a good data layer for what I would call user or document-centric applications. So let's define that maybe by what it's not trying to be. So it's not trying to be a good data layer where you build your next social network on, something like Facebook or Twitter. Those kind of platforms are very, very different in terms of like how you build them, like massive databases, highly connected compared to something like your Notes app, which is all about you.
Oh, I see.
And it's all about like, what is the body of content that is being created? Like, how is that structured? How does that grow? And how does that kind of sprawl? And in a social network, as the name suggests, you have a network of like highly, highly, highly connected things. But if you're thinking about your Notes app, that like your Notes app and my Notes app have unless we've shared something explicitly, has no overlap. And like all of my nodes easily fit on my phone, like forever. Whereas like all of the Facebook data doesn't fit on any computer at this point. There's like needs to be like dealt with entirely differently. And so I want to like embrace that like for some apps, not for all apps, but for some apps, it's much more like nodes like in size and like how it's structured. And so when you're building an app that's like oriented around a small group of users, let's say a family, a small company, even like a largish company, for certain kinds of apps, all the data fits into like a local database, or at least that you can say slivers of that app data fit into a local database. So when you think about, for example, linear, you could say, well, I'm in such a big enterprise that all of the linear workspaces don't fit on my device. However, I may be just like in those sub-teams, and all of the data fits on my device. And when you flip that and you think about like, I have all of my data locally, then you can build an entirely different data architecture. Since another thing to motivate here is like one of the hardest things in computer science and building apps are distributed systems. And I think this has really been like the most intense learning experience for me over the last couple of years, where I really needed to like face that reality. And I think it's kind of like the elephant in the room for many, many apps, and goes by many different names, whether it's like caching, cache invalidation, optimistic updates, etc. It's all sort of like different acknowledgements of like, hey, there's something really hard, and that is distributed state. And the only way how you can tame distributed state, that it doesn't become a game of whack-a-mole, is by like picking a certain architecture and then really embracing it. Otherwise, you'll constantly fight it. And this is where I'm starting with that architecture to have all the data local, and then work backwards from like making that an awesome experience. Since most web apps are different. They're like have their database not local, but they have their database somewhere on a big Postgres database in the cloud, and then they like fetch it, add a little bit of caching, add a little bit of optimistic updates, and that works as well as until the point where it no longer works, and you start like your app turns into a database. You had Carl on your podcast, I think 2 times, and he wrote this amazing blog post where like stop building databases, which makes the point that for most complex enough apps are accidentally turning into a database. And I 100% agree with this. And like my takeaway from this is, I think similar to Carl's, is like, hey, let's actually use a database to build our apps, so we can free up like 80% of like the mess that we've created trying to tame that data. And that just disappears when you start embracing a database. And now the second question for me was like, okay, that's how it works on a single device. But how do we build it in a way that like my iPhone syncs with your phone? Or like, how does this work across different devices? And so yeah, that just gives you a bit of like a starting motivation, or like how I've rewired my brain. And now I'm coming back to your initial question. So LiveStore, LiveStore is a SQLite-centric client-side data layer that supports cross-device syncing and cross-user syncing based on event sourcing. So we can explore more what that all means, but it's basically, let's say you're a React developer, you want to build like a linear-esque linear-esque app, and you're thinking, okay, how do I build that? Then LiveStore tries to be a good foundation for that. And so it replaces things like MobX, Redux, those sort of things, but that's on the client, but it also replaces the backend data layer for that.
Okay. All right. Let me say some of this back to you to make sure I got it all. So one of the points of view that you have as LiveStore is you are building for we can call them maybe like tenant applications, whether the tenant is a team, big or small, or an individual, but you're not trying to solve the use case of a large interconnected set of data. You want pretty clear boundaries on tenants, and that makes this whole process easier. And is that, or I think that is where you've expressed some of your opinionated nature is we're going to help and solve this use case, but not the other use case. Whereas with Prisma, you said, we'll be everything. We'll be all things to all people. Here you're saying, whoa. We're doing basically tenanted data. And so it sounds like another point of view that is opinionated and different from what Carl is doing, whom you mentioned earlier, is your syncing or your source of truth is the events. So Carl came on, a few episodes ago and was talking about Graph and basically, syncing blobs and little pages and little parts of pages, and nobody knows what's in the pages. We'll just sync them. And sounds like that works great for a lot of use cases, but you have a different opinion with this project that you're working on, and that is event sourcing. We're going to do event sourcing. And so I think you said LiveStore is a SQLite centric data layer that syncs events. Is that close to what you said?
Yeah. So I think there's two core technologies that for someone like checking this out, that you need to internalize, and then things start to make sense. So one is you have a SQLite database, and that SQLite database, this is where you read and query all of your data from. That is reactive, super fast. Like if you have multiple clients working at the same time, or let's say in a local web app, you have multiple tabs open, etc.
Okay.
You always query that database, and this is your primary place where you get stuff from, where you read things. But the question now is like, how do we write stuff? And how do we write this in a way that, in a distributed way, where like I'm having my web app open over here and I have it on my phone open over there. There's latency, the phone might go offline, etc. How do we make sure that those writes are all working correctly? This can mean different things. Let's say you're building sort of like a GitHub issues kind of thing. What should happen if two people one closes an issue, the other one still works on it as if it was still open, or they're just like conflicts that can happen. So the writes need to be dealt with much more intent compared to a traditional web app, where in the traditional web app, like a database can just say like, hey, we start a transaction that might run a few 100 milliseconds, but no one is dealing with that data until the transaction is done. But in this local firsty way, now those transactions might actually happen locally without knowing what's going on over here. So you need to reconcile that somehow. And this is now where event sourcing comes into play. Since we've kind of like looked at these problem statements before, and this is what led to, like back in 2011, I think, or 2014, led to Facebook introducing the Flux architecture. So the Flux architecture later famously led to Redux. Redux was like, I think these days it's not as big anymore, but the ideas behind it, I think, are still very relevant. And I think we'll have sort of a renaissance of those ideas. I'm certainly embracing them with LiveStore. And the idea here is to not have your state be directly mutable. So in this case, if your database is you're representing your state that is being synced across clients, you don't directly write to that, since at that point, when you have mutable state, things get messy. You don't know exactly when something has happened, why something has happened. You don't know quite what is the source of truth. When you have that, you also need to think about database migrations. That becomes a big problem as well. So I got fascinated with the ideas behind event sourcing, where there's a fair bit of like literature around it. It's been mostly employed as an idea more on like microservices, etc. Martin Kleppmann has written a fantastic essay about it, calling it turning the database inside out. But the same ideas really apply to Redux, and the JavaScript ecosystem had internalized those ideas before. And I wanted to reapply them now, but in combination with SQLite. And the idea is basically, instead of, let's say you building a linear app and you have a button that says create issue, and you create it, instead of applying the insert into issues statement right away, you create a event that says like, hey, the user wanted to create this issue. And then you apply the insert into table statement. But then instead of syncing around that insert into SQL statement to other clients, you sync around that event. And now those other clients, if everything goes well, they can just apply it. But in case they have dealt with something locally that kind of conflicts with this, now it's way easier to think about that event. As opposed to deciphering a CRUD-like SQL statement. And so that has many, many benefits. Just to name a few, it helps you to deal with like local first apps in this distributed setting, but it also helps you with just taming your database more broadly. When you have a certain state in your database, you might actually have that kind of be duplicated across your app. And then you don't quite know, like, hey, is this the source of truth of that data, or is that the source of truth? And with event sourcing, you know this event is the source of truth, and we can completely reset the database and rebuild it from scratch. And that is also implies the kind of like a trivial solution to schema migrations, since if you now want to change the schema of your SQLite database, then instead of like manually doing that, you can actually fully throw away the local SQLite database, run through your entire event history again, and apply it to your new database schema. And that was a surprisingly motivating use case for me, coming from Prisma, where I've like tried for over 4 years to make database migrations nice. And you can just only do so much in that architecture. Yep. And with event sourcing, it has the most beautiful solution to schema migrations, which is like to not do them at all. And so there's the more you pull on that event sourcing thread, the more kind of like positive benefits come throwing in your way. Another one is time travel. I'm not sure for those listening who tried out Redux, one of the amazing things about it were the Redux DevTools, where you got like that time travel feature, which just blew my mind back then. And that's something you can now get in combination with SQLite, etc., and Signals like reactivity system around it. So basically just trying to combine different ideas that were already kind of explored in isolation in the past, and now putting it together in a nice modern data layer.
Well, you make a compelling argument for event sourcing. So let me ask you this. So you said there's a local SQLite database, and instead of just writing, insert into to-dos or whatever, you fire an event, and the event is insert to-do, and the payload is, name and body and, due date or whatever, right? So you have this envelope of data. You've got this event, and this is your source of truth. Now, talking specifically about LiveStore, you're in the browser. You fire off this event from, Vue or React or whatever, and you fire that into LiveStore, and at that point, LiveStore takes over and does all of this stuff. That's the first question, and the second question is, where are the handlers written? So do you have to have the event handler on every client? Is there some sort of centralized backend state? Who is doing the translation of create or insert to do into, insert into tables to do? Where does that transmutation happen?
Right. So let me just double check. Connection should be good, but I have the question still in mind. So let me start out first by saying that the event should actually not be as cruddy in nature as you made it sound. So the event is not insert into to-dos, but the event should be almost like if a business person would have written it. A business person who's not an engineer. And it says like, hey, in this case, it might be like, hey, I created a new to-do, or later I completed a new to-do. So instead of saying I updated to-do and set complete to true, a more natural way to describe is like, hey, what did I do with the thing? I completed it. Or a user signed up. So instead of like a user was created, a user signed up. Since we might later want to reinterpret what that actually means. So this is where the ideas of like domain-driven design and domain modeling come into place. And like ultimately, we're building software to make a certain real thing happen. And now we should model it after that real environment. And
so the event should describe what happened, not try to imply what you should do with it. You just describe what happened.
Exactly.
Okay.
It should capture whatever context about that is relevant. So when a user signed up, the context that is relevant is their name, is their email address, is maybe whether they want marketing mail or not. But how we deal with that later, whether we write it into a customers table or into a users table or into employee table, who knows? We might completely change our mind later when we deal with this. But what is important is like a fact, not a snapshot of the entire thing, but like all the contextual information that is relevant to this thing that has happened. So that distinction is like fairly important. I think sometimes they're like very close together. But sometimes it also makes a huge difference. Like, for example, if you're building a shopping system, you say like, hey, the order was submitted. What that means in your actual like e-commerce system, there's probably rights to like 8 different tables doing something crazy. But domain-wise, like, hey, the customer has submitted the order. So with that out of the way, let's look into the mechanics of LiveStore. So there's the SQLite database. And then there's also something called the event log. So all the events.
Okay, first of all, are these all? Yeah. Is this all in the browser? Where are we living when you're talking about this?
So LiveStore is pluggable. So I have platform adapters for various platforms. I have currently one for the web. I have one for Expo, so that you can run it on iOS, Android. And I have one for Node, which also runs in Bun and Dano, etc. There's plans for Electron, Tauri, etc. So it will be cross-platform. But let's work with the web example for now.
Let's start with the web. So we have a database. Keep going.
So we have locally, we have our web app, and remotely, we have some sort of sync backend. The sync backend is basically only accepting those event messages, and we're connected to it somehow. So locally, let's say a user clicks a button. Let's say they say, hey, this to-do is completed. What happens? somewhere in, let's say we're building this with React, there's a React click handler. That React click handler runs some code. The code it's running is as store.commit to do completed. So store.commit, LiveStore syncing is like very Git inspired. And so when we're changing something in Git and we're happy about what we want to do, then we create a commit from it and then we push that commit. It's very similar here in LiveStore. So we commit an event, the event we've designed according to our app. So here we say, hey, we want an event that captures when someone completes a to-do. So we just say store.commit events.to-do completed. We capture maybe the to-do ID, maybe the time when it was completed, everything that's necessary for this event. And that is then committed to the event log. It is immediately also applied to the SQLite database that the UI updates. And it's done so through a thing that's called a Materializer. If you're used to Redux, then those things were called reducers. Given that we're here not just reducing into like a JavaScript variable, but we're going through this database, there is like the concept of materialized views. But you're materializing state, and that is the name I've chosen here. So your event is being materialized into the database by you expressing how that should happen. And that is typically, here would be a simple update statement, like you just update a row in the database. But you could do whatever to the database in response here to that event. So again, you commit that event. The new event is added to the event log, immediately applied to the database by flipping the, probably like in a to-dos table, flipping the completed to true. And that refreshes React immediately. So you have on the next frame, you have your expected state. And then in parallel, if you're building an app that's actually also syncing, which is optional, but let's say you're building an app that syncs across devices, across clients, then that event is also pushed to the sync backend. The sync backend just like accepts it. Think about it as like a Git server. It might reject it because you have maybe fallen behind. But let's say it accepts it. It writes it into its own event log, and also then sends that down to all the other clients who are constantly pulling. And then all the other clients basically just add it to their own event log, materialize it, and poof, it's reactive in the other clients. And that typically happens within milliseconds across the network.
Okay. That's a very helpful life cycle. Let's start back with the React click handler. So on click, or whatever y'all call it, on click, store.commit, and then you commit this event. And you said the event, and inside the event is some payload. The event goes to the event log. What is technically the event log? Is that a discrete entity from the local SQLite database that holds your materialized state?
Yeah, so it's currently, it really just needs to be a persisted list of events that could be stored however you want. You could even put it in local storage or something. As you can maybe already guess the answer, but that itself is a separate SQLite database, just because I have all of the SQLite machinery already in place, and it's super nice to work with that. But that is really like the simplest SQLite database you can think of, a single table, which is called event log, where you just append only those events. But those are separate SQLite databases for that reason, that if you want to change your main SQLite database, let's say you have currently a to-dos table and you want to completely change how you want to model that. Maybe you're really like building a version 2 of the app and it's now called issues, and there's another one that's called tasks, and there are different things. So completely new schema. What you do is you change that schema to whatever you want. You adjust the materializers, and the next time the app boots up, a fresh database is created. It runs through the entire event log, and your app is in the new desired state.
Okay. So you're writing to you do store.commit and it writes to an event log that is backed by something. Most of the time it's going to be backed by a separate SQLite database, just a big old table. Then after the event has been committed, so your source of truth has been updated, we have a new thing that has happened. Then we have to take that event and materialize it onto, I don't know what you call it, the application database or the state database or whatever. Presumably, you wrote the code that says turn this event completed event into, or to do completed event, turn this into a SQL statement. So that is, do you call that the materializer? Is that the name you give that thing?
That's right. Yeah.
Okay. So the materializer runs because a new event has been added onto the stack that has not yet been materialized. So this materializer, does this live in the application? And so every connected client is expected to have the same materializer code? Or is this somehow, I can't imagine how, passed in the event so that clients can run the materializer without even having the materializer? Where is this materializer written?
Yeah, so you're asking like how are things bundled and pushed across the boundaries?
Yeah.
And so given that we're dealing with JavaScript here and you famously can't like serialize JavaScript functions easily and send it across the wire, there's certain parts that your app is expected to already have when it boots up, and then some data is sent over the wire. So let's assume the scenario where the different clients you're running are actually, they're really like the same kinds of clients. In that scenario, you would basically just, you push app version 1.5, you push it to your CDN, the various apps boot up, and they all have the same LiveStore schema. The schema is really just like, how should your SQLite database look like? How do your events look like? And what are the materializers code? So all start up with the same code and they all work in the same way. And that basically also means in the unlikely scenario where you have a app that wasn't upgraded yet and it somehow sees a new event that it hasn't yet been ready for, well, that is then kind of like, it just puts it to the side, freezes the app in sort of a way that you should render like a message which says, hey, like upgrade your app, please.
Got it. Okay.
But the materializer code, which is like a materializer sounds more complex than it is. It's really just like, it's a callback function that returns a SQL statement. LiveStore has like a kind of query builder thing built in that makes like type safety, etc. nicer, but you can use whatever you want there. You can use Prisma at some point. You can use Drizzle. You can use raw SQL, whatever you want. But yeah, materializers, super simple, but they need to be part of the app. What you could even imagine as well is that maybe there's a different kind of client. Maybe it's sort of like a admin dashboard where you rather want to track how many to-dos were created today. You could also say, actually, I want to materialize that entirely different. And I rather want to have like a count table that tracks that. And so you can have just a different kind of client, but they're all working over the same event log.
That's interesting. So you don't have to, this is obvious now, you don't have to materialize it the same way in, like, at the same time. I think I've been thinking when you're like, you can change how you materialize it. That's when you say, whoops, I messed up. Let me change my schema and then replay all these events. But you can materialize these things differently in different applications. And so right. I'm thinking the materializer is pretty important. We got to make sure every client has the same materializer, when in reality, every instance of a particular client does need the same materializer. We have it open in 2 tabs. We want to make sure we're materializing the same way. But you could have a desktop app that materializes differently, a separate web app that materializes differently, a phone app that materializes differently. And so it doesn't super matter, and it doesn't make sense at all to try to embed the materializer into the event, because then obviously you can't change it later because the event log is supposed to be immutable. Okay, this is all starting to come together for me. So
and just to recap, sort of like a main point here is about what can you change later and what is the source of truth. The events are really the only source of truth here, and everything else is downstream. And I think that really nicely expands on what I love so much about React, that React famously was introduced as like the UI is a pure function over the state. Like UI is F over state. And now we basically can apply the same like beautiful concept here, that like that rendering, that is like that's a pure function. I think by now we are not as afraid of like saying pure function, because in the past it was sort of like functional programish, but with React we all know what is so nice about this. And the cool thing here is like LiveStore applies the same idea twice. So it says basically UI is F over state. The state is just a query for your database, which is also a pure function, like, and synchronously returns. This is, you always know what you get when the database is in a certain state. Querying that always returns you the same data. And now the question is, what is the database? And the database is a pure function over how you materialize the events. And so you basically have like 3 pure functions, super easy to think about, super easy to like reproduce. If something goes wrong, you like, that's always one of the hardest things. Like, something goes wrong, how do I reproduce it? How do I test for it? And there's no easier code to test for than synchronous code, pure code. And so that is, I think that's sort of like the superpower of LiveStore is simplicity.
Yeah, this is really cool. I've always admired this part of React, not all of it, but I've admired this part of React, that they were very clear that the UI is a function of state. And I thought, yeah, that makes a lot of good sense. And so going all the way down the stack, you've applied that same idea. So the database, what we're calling the application database, the database is a function of events, materializing events. So at the very, very bottom, the bedrock is events. They are forever, they're immutable. That is our source of truth. Then you apply a function. And they're easy
to think about. They're very easy. Like, it's one thing at a time. They always happen in the same order. And like, like this has happened and this has happened. And you can like deal with that however you want.
Yes, and they're discrete. They're nice units. Like they're not messy. They have clear boundaries. So you have events, and then you apply a function on top of that, and you get a database out of that. Then you have a database, and you apply a function, which is a query, and you get some sort of state that you can then, put in your application. And then you have your state, and you apply a function, and you get UI, and that is React. That part is React. The other 2 parts are you. So this
entire thing is reactive.
Makes a lot of sense.
So it's like all a pure function, but it's reactive. Yeah. That means if you click the button, all of those stuff happens within like a fraction of a millisecond, and is ready for you in the next frame. So it's everything super simple and super fast.
This is clean. I like the discrete boundaries and the ease of reasoning, because, like, I know that we'll go back to Carl. Carl's doing some amazing and powerful work, but it's a lot to think about these individual pages and blobs, and like that obviously serves a very important purpose, but this is very discrete, and I like that. The boundaries are very clear. The envelopes are very clean. That makes a lot of sense to me. You said this is all so far self-contained. This is all isolated inside of one browser tab. You mentioned when it goes to the event log, it can propagate or replicate or sync out to someone else. And I imagine that is a centralized syncing server. Is that true? And if so, talk to me about this centralized syncing server.
Yeah, that's exactly right. There's like one middle step that we could actually talk about just for the sake of completeness. So even if you don't have that centralized syncing server, they're like you're running a web app, maybe sometimes not just in one tab, but maybe in multiple tabs or in multiple windows. And how do you deal with that? Not every app is commonly used in this way, but let's say we're building Notion. And in Notion, I often have like multiple different pages open at the same time. And sometimes I even have the same one open at the same time, or they reference similar data. So let's say I'm like building a more like offline-ish Notion thing, a way simpler one. But the core thing here is really I have state that is kind of the same state that I want to have in both tabs. So most web apps only work in this way by going through like an API, and it's sort of like almost comical if you think about it. That
going
like
from your browser out to Virginia back to your browser.
Exactly, just that you have the same data in your two different tabs. Gets even more comical if that breaks. But LiveStore is built in this sort of like hierarchical way where there is like layers of syncing. And the simplest layer of syncing is like how a single tab syncs its state also to like a written database, that if you like reload the app, that the SQLite database doesn't suffer from dementia, but it still knows exactly what it had before. And then the next layer of syncing is that it syncs between different tabs or different windows. So when you say you build an Electron app, you have multiple windows, or in a browser, you have multiple tabs. So LiveStore's syncing thing already starts locally, where it just propagates those events across those tabs. It's the same thing. If you think about this as sort of like the flux, like data flow, unidirectional, it basically does the same thing in each tab, and then also propagates the events between the different tabs, that they all end up in the same state. Doesn't mean they have to show the same pixels, but they still have all access to the same SQLite database. And that same idea is then just reapplied again in a more global way, where you now, instead of syncing the events between tabs, you now sync it to some backend service, and the circular loop is just a bit bigger.
So can we pause and back up just 1 second? I'm not familiar enough with Chrome's tab isolation and the nuances around local storage and WASM and all of that stuff. So in the instance where you've got the Notion thing open in two tabs, are they able to look at the same event log, or are those in sandboxes and you literally do have to like send an event over the wall to the other tab? How does that work at a technical level?
Yeah, so there we can get very technical.
Let's go medium technical.
Since there's like multiple ways to do that, in case someone wants to roll something like this themselves, the easiest way to accomplish this is to create something that's called a broadcast channel, which is basically like you instantiate that thing called new broadcast channel, and then you give it a name, say my channel. You do that in both tabs, and then you can just post messages to that and listen to messages. That is the easiest way to do cross-tab things. There's also other ways. You can abuse local storage for that, to kind of like each writes to local storage and the other one just listens if something has happened. You can also use index.db for that. What I'm doing for LiveStore is I'm using a shared worker that both instantiate. The reason for that is that SQLite is binary data, and I can't just like send messages that are like always encoded as a string, but I need to move memory. Like if you're familiar with Rust, etc., you know the difference between copy and cloning data as opposed to moving. I need the move equivalent here, which JavaScript gives us with transferable primitives. And so that's basically how I create this little connection between those two tabs. And that shared worker is basically acting as like a little mini local sync backend. that all the ones talk to. And then if you're using like proper syncing to like a backend, then that thing just propagates it even further.
Okay. Didn't know any of that, so that's very helpful. Thank you for explaining that.
The web is amazingly capable. I think there's so many untapped potentials that it's incredible what the web can do. I think it's just that we've been kind of thinking about building web apps more kind of like React server component down as opposed to like capabilities up.
Mm-hmm. So in this sync lifecycle, let's expand. I think you said a little more, make the loop a little more global. So at some point, I guess the event log says, hey, I got a new event, and then it probably loops through everybody that it should sync to, whether that is local or global, hand wavy, and it syncs out the event to something. Is that sync server, is that basically just running LiveStore, but on something that is persistent, whether like a server or durable object, or could it even be a fleeting Lambda? Like, where does this sync server run, and what does it do?
Right. So a sync server is conceptually super, super simple. It is an endpoint that receives messages, receives pull requests or push requests. So a pull request is like, hey, give me all the events either since the beginning of time or since event 100. Like event 100 is the last one I've seen. Give me all the new ones. And a push request is like, hey, I have like those 2 new events, please accept them. Very similar again to like how Git push pull works. Semantically also very similar in that regard. If you're trying to, like with a Git client, if you have a local commit and you push and your colleague in the meanwhile has pushed some work, you need to like first reconcile that. You can do that through like a rebase or otherwise. In LiveStore, you do that through a rebase as well. But that sync backend, its only job is to accept those pull and push requests. And the only nuance there is that the push request needs to enforce this total order. That basically means like if the last push was 100 and our client comes along and says like, hey, please take event 50, and it says, I'm already at 100. You're probably out of date. Here, please pull all of like the newer stuff first. That it's always like in the same order. But that's really it. And so a sync backend is very, very simple, and you can put you basically just need to persist the event log. You can persist the event log. You can keep it all in memory. You can put it into a Postgres database. You can put it in D1, Torso. And I think that's also attractive about this because it is conceptually so simple. And this is where you might also want to apply business logic that is specific to your app. So this can just become part of your normal app backend that might do other things.
Okay, yeah, that's pretty cool. That is very simple. So you really could run it anywhere as long as you have a place to put the event log and hang on to it. So then other clients out in the world, as a part of what lifecycle are they checking the sync server? So like at what cadence or what event, or how does that like phone home process work?
Right. So it kind of depends on which sync backend you're using and what the capabilities and constraints there are. So a common sync provider that can be used with LiveStore is like a Cloudflare worker sync provider. And this is where we can use all the benefits of Cloudflare workers with durable objects, which gives us WebSocket connections. So through its WebSocket connections, we have like that network reactivity. That means if client A pushes something, client B doesn't need to like poll and like hope that something has happened, but client B gets like a message right away. So it knows like, hey, something new has happened. And you get that real-time feedback loop. But
so in that case, the sync server receives an event and then lets every WebSocket that's connected know it's just received an event.
So that is like a slightly smarter sync backend that basically additionally to doing push-pull, it does like a poke.
Notify or something.
So the folks from Rosie Corp who previously built Replicache landed on a very similar architecture. And again, it's like very, very simple. And you can, depending on what hardware you're using, what sort of like network primitives, you can use certain things that are, for example, easy to operate, cheap to run, etc. So WebSockets are an amazing primitive for that. But you could also very well just do HTTP polling or server send events. You could do something very, very different. I have like this little side quest where I want to use just plain Git as a sync backend, where you'd basically just use a Git repository as a sync backend, and your apps would collaborate on a Git repo, which would be kind of like meta. And I just wanted to
so meta.
Like, but it's very simple.
That is super cool. Okay, this whole life cycle is making a lot of sense to me, and like I said earlier, I like the ability to reason about it simply. You can still build really complicated stuff, but you can reason about it very simply. That's exactly makes right. That makes me feel very warm and fuzzy. So as we're finishing up here, tell me the state of the project right now and your hopes and dreams for the future, and how people can help you see this come to fruition.
Right. Before answering that, I just want to say, like, doesn't all come without trade-offs. So this is like built for specific applications, and I don't want to say, hey, this is the best technology ever. There are trade-offs to this, and there are apps that this works well for, and there are apps, use cases where this doesn't make as much sense. We don't have much time to talk about that. I just don't want to be seen as sort of like ignorant and naive about this. This is like for specific application use cases, and I'd be happy to explore those with whoever's interested in it. But I just want to make sure this is well understood.
Johannes, you are a man after my own heart. You are an exceeding reasonableist. I very much appreciate that. Nobody thinks you're claiming to have invented the panacea, but it sounds like you have created something that is very useful for the use cases you're trying to solve. So I do appreciate that disclaimer. So keep going.
Thank you. And I'm modeling it around my own use case, and I think that's the best way to build something that. So the state of the project, it's been in development at this point, since over 4 years, really. It had its first live through this Riffle research project, and then over the last 2 years, that was the SQLite reactive foundation, and now over the last 2 years, I've productionized it further and added syncing on top. So currently, LiveStore is in beta. There is no concrete point in time yet where I would say this is 1.0. It is probably another year away or so. I'm building a community of contributors and maintainers around it who are already starting to help me get there faster, since this is like a very, like, for example, just making sure that this works across those different platforms. And given that this is trying to tame distributed systems, that's a really big effort, and it's probably the most ambitious and complex system that I've ever tried to build, and I'm building. So this is not just your normal JavaScript state management library. This is a more complex thing. And I'll probably I have full intent to keep working on that within the next 5 years or so, maybe beyond that. I certainly have a roadmap for that keeps me busy for the next decade or so.
Wow. That's crazy.
One thing we haven't even talked about is like it has first-class dev tools, which is a Chrome extension or like a Expo extension, which allows you to look into it. So the scope is fairly even though the core is simple, the scope of like what this thing can enable is fairly ambitious. So yeah, but I've been working on that mostly full time next to working in Overtone since the last 4 years. And my hope is that similar to how React has just completely changed like how capable the web can be, I think there's like a similar opportunity just to do the same thing for data for a specific kind of application. There's other folks who are building systems to address other use cases, and I'm trying to build a system for the kind of Overtone linear-esque use cases. And that's what I'm trying to build. So if this technology sounds interesting to anyone, please give it a try. We have our cozy little Discord community where we help each other. We have a nice community of contributors. We're doing office hours regularly. And I'm also building this in a different way compared to Prisma, where we've raised VC money. I'm bootstrapping this thing, and I'm trying to make it a sustainable open source project, which has its own challenges. So I'm leaning heavily into GitHub sponsorship. So far, the project was invite only for GitHub sponsors, but we're just crossing the boundary into open sourcing the project. So awesome. I think this has happened at the point this episode comes out, which I'm very excited about. And yeah, now it's available to everyone. And I hope that I find a sustainable path forward where this can be a great foundation for many apps.
Wow. Well, thank you for coming on and explaining all that. The stuff you're doing is amazing. And I will be very candid and say having a 5 or 10 year roadmap for an open source project is pretty inspiring to think like, yeah, you're gonna stick with this for a long time. I mean, it's been a long time already, goodness, but to have that kind of like dedication to it is very inspiring. So for those of y'all listening, if you want to join along, I will leave links to the projects and the repo, and Johannes, if you can send me the link to the Discord, I'll leave that down in the description as well, and a link, of course, to Johannes on X and everywhere else that I can find his stuff. So please, if this sounds interesting, reach out, check out the repo, give him a sponsor, give him a star. Sounds like very, very cool work, and we want to support that, especially this open source stuff. So Johannes, anything else you want to leave the people with before I wrap it?
No, this was wonderful. Thank you so much. Yeah, and if this entire local first thing is interesting to anyone on the Local First Event podcast, I have a whole bunch of really interesting guests, from the founder of Linear to the folks who built Dropbox to people building whole new operating systems around Local First. So that's a particular niche that I feel very at home. And if that sounds interesting to you, that's maybe also worthwhile checking out.
Yes, good idea. I will leave a link to that as well. And I imagine the people that are interested in this type of show are interested in Local First FM. So yeah, y'all head over and check out Johannes's podcast as well. And my request for the people is, if you have people that would be good on this show, please let me know. If you have friends or you yourself would be good on this show, if you're actually building something like Johannes here, that's who I want to talk to. People who are building things in and around the data space. So please, if you know of someone or are someone, reach out. And if you're listening on audio, we do have YouTube. And if you're watching on YouTube, we do have audio. And we'll leave links to all of that down below. Thank you all for tuning in to the nerdiest podcast in the world. It is an absolute delight for me to do that. And so thank you for listening. And again, please go check out all of Johannes's stuff. And until the next time, we'll talk to you soon. See ya.